high, h equal to 4 meter, and radius 2 meter, r equal to 2 meter, is buried so that the top of the tank is 1 meter below the ground level. So here we have a tank is underground. The top of the tank is 1 meter below the ground level. If the density of water is 1000 kilogram per meter cube, that's the rho. How much work is done in pumping a full tank of water up to the ground level? So you need to picture this carefully. We need to draw a diagram of that in order to figure it out well. So we got the tank full of water, and what is the height of the tank? 4 meter is the height of the tank. The radius of the tank is 2 meter. Now we take the origin at the bottom. So this is the origin, y equal to 0. That's the y-axis. This is the x-axis. And we take a layer of fluid at a distance y from the origin, and the thickness of the layer is dy, and the distance of the layer from the origin is y. So this layer is the disk of radius 2 meter and thickness dy. And where do you need to take this layer? Now remember, the top of this tank is 1 meter below the ground. So if this is the ground level, you need to pump the water all the way to the ground level. Well, let's first of all find the volume of this disk. The volume of the disk is, from our last discussion, you know what the volume is. The volume of the disk is pi r squared times dy. So let's put that down. Volume of the disk is pi r squared dy, and r we know, so we replace r by 2. That gives me 4 pi dy is the volume of the disk. And what is the mass of the disk? Mass is volume multiplied by density, where density is 1000 kilogram per meter cube. That will be 4 pi dy is the volume times rho is the density, which is 1000 kilogram per meter cube. And that is 4000 pi dy. That is the mass of this disk of fluid. What is the weight of that disk of fluid? Weight is mass multiplied by g, where g is 9.8. So that will be 4000 pi dy, which is the mass, multiplied by g, and that will be g is 9.8. And that gives you 39,200 pi dy is the weight of this fluid. In other words, in order to lift that disk of fluid, in order to lift it so that you can pump it, you need to apply a force equal to 39,200 pi dy. This is the weight, or that is the force you need to apply to lift it so that it can be taken out. Alright, so we now know the weight of the disk. Now, this is a measure of the force needed to lift the disk. Now, the position of the disk can change from y equal to 0 to y equal to 4. This disk can be anywhere in the tank. It can be at the bottom or anywhere between the bottom and the top. That means the value of this y can change from y equal to 0 at the bottom to y equal to 4 at the top. That's right. Now, the top of the tank is 1 meter below the ground level. So if the ground level is over here, which I don't know whether you can actually see that yellow line I have put. Now, the top of the tank is 1 meter below the ground. That means if the height of the if the height of the tank is 4 meter, the bottom of the tank is actually 1 plus 4, and therefore tell me what is the distance dy, what is the distance dy the layer is lifted to take it to the ground level. In other words, what is the distance that this layer has to be moved to take it out to the ground level? Can you tell me what that is? Well, if you notice, that is the ground level, and the total distance, the height is actually 4. 4 plus 1, 5. So this total distance is 5 meter. And the layer is at a distance y meter from the origin. So the distance this layer has to be lifted so that it can be thrown out is this total distance, means from here to the ground is 5 meter minus y, because the layer is y meter above the origin. So the distance from the bottom of the tank to the ground is 4 plus 1, 5 meter. That's right. The distance of the layer from the bottom, the distance of this layer from the bottom is y meter. So again, one more time. The distance of the ground from the bottom of the tank is 5 meter, and the distance of this layer from the bottom of the tank is y meter. Therefore, the distance this layer has to be moved to take it out is 5 minus y meter. So that is the displacement of that layer. Alright? So that distance the layer has to move is 5 minus y meter. Therefore, what is the work done to move this layer to the ground? What is the work done to move this layer of liquid to the ground? It will be the force that you need. What is the force? The force is 39,200 pi dy, and this force needs to move through this distance. Therefore, the work done will be force multiplied by the distance. Work equal to force multiplied by distance, and we call that dW. The work done to move this layer is dW, this is the force and this is the distance. So that is the work done to move that layer. And now, to get the total work done, what do? All we need to do is integrate that dW from y equal to 0 to y equal to 4, because this can be anywhere inside the tank from y equal to 0 to y equal to 4. Alright, we will rewrite the dW as, take that dy to the end. That is the conventional way to write it. So that will be 39,200 pi minus 5 minus y dy is dW. The total work done is obtained by integrating this dW from y equal to 0 to y equal to 4. So that's y equal to 0, that's y equal to 4. So total work done is integral 0 to 4, 39,200 pi times 5 minus y dy. And this constant now comes out. That is 39,200 pi integral 0 to 4, 5 minus y dy. We can now integrate these. These are very simple integrals. What is integral 5 dy? It is 5y minus, what is integral y dy? That will be y squared over 2. So that will be 39,200 pi times integral 5 dy is 5y minus integral y dy is y squared over 2, and y changes from 0 to 4. We can now apply the limits, apply the upper limit. Of course, you don't need to apply the lower limits because it is 0. So that will be 39,200 pi multiplied by 5 times 4 minus 4 squared over 2. And that's a very simple calculation. 20 minus 8, that will be 12. And multiply there, that will be 470,400 pi joules is the work done in pumping all of this water to the ground level. Alright, I want you to watch this one more time and make sure you understand the various arguments we were using, especially the distance the layer has to move so that it can be taken out, knowing that the ground level is 1 meter above the top of the tank. Alright, let's try another problem. An open tank has the shape of a right circular